So I'm looking at your lab sheet right here, and the important reactions to look at are these. They show the reaction of copper, one of the ingredients in sterling silver, with nitric acid, shown here as two separate ions, and also the silver with nitric acid. Now you may remember that we looked at only the second reaction. It's a safe assumption for us to assume that the whole coin is made out of silver, 90%, which is the actual value, very close to 100, and since what we're dealing with is a reasonable approximation of the amount of acid to use, we won't go wrong using the silver here. And that's what I, in fact, instructed you to do in the first place. So if we just look at the second equation, then we can forget about the first one for a moment. We can see that it's balanced, and it's actually a really nice ratio to work with. We have 1 mole of silver reacting with 1 mole of the acid. A 1-to-1 ratio is about the nicest one that we could hope for. So knowing that, that means however many moles of silver we have, we're going to want the same number of moles of nitric acid. Now, since we want the nitric acid to be present in excess, basically we want the silver in every single step to be the limiting reactant, just like with the sodium chloride. We're going to estimate up a little bit, and I believe I told you to estimate up by 20%. Once we find the number of moles, we'll multiply it by 1.2, basically take 120% of it, just to make sure that our value is high enough. And it's not much acid that should be strictly necessary. I know we ran into some issues just getting the acid to cover the coin, but the number of moles of HNO3, this nitric acid, would really be necessary, not so great. Now, I know that most of your coins were somewhere around 2 grams, so that's what I used here as an example. And clearly this is a simpler version of some of the math that we've done without the ability to draw fractions for you right now. But if we assume that the coin weighed 2 grams, we'd convert that to moles by dividing by the atomic mass, or the molar mass of silver, and that would give us approximately, and I'm rounding here, 0.02 moles of silver. Now what you're missing here is the part of the fraction that would on top say 1 mole of silver, but you get the idea. Now we can see that we'll say if we need 0.02 moles of silver, we want that same number of moles of nitric acid, HNO3, and here's our estimation up, multiplying by 1.2, or 120%, to give us slightly more moles. Now, this acid, it does not come to us in a pure form. Like the bottle that you used was not totally full of HNO3 molecules, it was a solution. And actually it was mostly water with some HNO3 dissolved in it. That's just the way that we typically encounter acids. This particular acid had a concentration of 6 moles per liter, or a 6 molar solution. So if I take the number of moles of HNO3 that I want to have, and I divide by the concentration, remember this concentration is in moles per liter, I'm dividing so you could picture that fraction actually inverted, upside down, where there would be 1 liter on top of the fraction bar, and then 6 moles at the bottom. The moles and these moles would cancel out, leaving us with, it's really 0.003 liters. I went ahead and converted that to milliliters, and it would be 3.71, a very small volume.